non-numeric. So fuzzy logic should be a very powerful tool. And we've got some examples to show you here that Marco worked on the last 2 months, which gives us some ideas about moving forward in complex systems. This is a complex system because there's political issues, social issues, economic issues, technical issues, and cultural issues. Investors will put money in if they see a way that all of this is being addressed. Not just the tests we've done in the laboratory to show how strong this stuff is. Not just the tests we've done with treatments to show how long the material will last. So, he looked at 4 different approaches. Fuzzy C-means classification, fuzzy cognitive maps, fuzzy agent-based models, possibility distributions. Let me start with this one first because it's real quick to dismiss. I already mentioned that bamboo is something that one number is not going to work. You need a range of numbers. The diameter is 8 centimeters on this end, and it's 12 centimeters on that end. That's an interval from 8 to 12. It varies. The thickness varies a little bit too. The length between the nodes, the diaphragms, that's not a constant. That's a variable. Okay? It's an interval. It's not a number. Possibility distributions are used to assess collections of intervals. I don't have time here to give you a lecture on how it's done. It's very powerful. You get what's called a possibility distribution. If you have a collection of numbers, just single scalar values, you get what's called a probability density function, right? A probability distribution. That's if you have a collection of numbers. If you have a collection of intervals, you have a different kind of uncertainty. You have an uncertainty called non-specificity. I don't know what the diameter is, but I know it's between 8 and 12 centimeters. That's what I know. It's a different kind of uncertainty. So you need a different model to work with. It's not a probability model. It doesn't deal with randomness. It deals with intervals. Okay, fuzzy C means we started working with this because of the issue I addressed earlier when I said that we don't have design tables. We don't have the knowledge that tells us which species of bamboo would be best used for beams, which species would be best used for columns, which species would last the longest in a wet environment, a dry environment, an environment where the temperatures are minus 20 Celsius, an environment where the temperatures are plus 40. We don't have that. What we could get it, if we do, it's called classification. So we worked with this. This issue here, cognitive map, a cognitive map is a kind of a modeling tool where you have some concepts that are related to one another, like social issues, political issues, economic issues, technical issues, issues with skilled labor, issues with competition, issues with profits. These concepts are what an investor needs to see, and they're related somehow. When one goes up, the other one might go down. When one goes up, another one might go up. And so you have this map of these concepts that are related by what's called causal effects. How do you say that in Portuguese?
Causa.
Huh?
Causa.
Causal?
Causa. Efeito.
Causa efeito.
Yeah.
In other words, one is affecting the other, and they all affect each other. And it's not really clear. You can't throw. It's real difficult to assess this thing with just numbers alone. Now there are numbers, of course, because we want to study what the effect of a change here has on the overall model or individual elements of the model. So you'll see that map, and then the fuzzy agent-based model. I'm not sure. I'll get into this as far as we can because we're running out of time, but this is a very powerful tool. This is new. Agent-based models exist, but not fuzzy agent-based models. Agent-based models do something that standard fuzzy logic doesn't.